Well, we can't actually see the spacecraft. It's very far away from the Earth. But what we do is we use the deep space antennas to communicate with the spacecraft. And so what it does is sends back signals that we can read. We measure the Doppler shift and measure the time it takes for the signal to go to and from the spacecraft. By taking those types of measurements, we can infer where the spacecraft is and where it's going to be going at any given time.
The challenge that we have is the spacecraft is so far away from Earth that the signal strength we receive is really very, very small. Now the spacecraft is sending zeros and ones, which are the information. And what happens is you can have noise from space, from charged particles circulating around the Earth, the atmospheric effects. All those things, in essence, add their own zeros and ones to the data. So on Earth, we have to hear this very faint signal and try to figure out what the spacecraft is saying. What was indeed zeros and what was indeed ones. The challenge that we have also with spacecraft is that we're on the Earth and it's spinning. So from a given antenna complex, a spacecraft will appear to rise off the horizon, go overhead, and then set on the other side. And a pass, when you can contact a spacecraft, is about 8 hours a day. So what we do is we locate our antennas all around the world, separated by 120 degrees. There's a complex out near Madrid, Spain, another near Canberra, Australia, and then right here in California. So what happens is an antenna will track the spacecraft as it rises and then through the zenith and as it sets, and before we lose contact with it, we command another antenna in another site to actually pick up where the other antenna left off and then track that one. So it's a series of acquiring the signal, tracking the spacecraft, and then handing over to the next antenna as the Earth spins. There are approximately 30 different spacecraft that we need to track, and they're all around the celestial sphere. Some are heading to Saturn, some are going to Mars, some went by the Sun, some are going after comets. They're all over the sky. And unfortunately, they're not evenly distributed across the sky, so that if you have 4 or 5 spacecraft in one part of the sky, which means a given antenna now has to choose between which one of those spacecraft to talk to and listen to. And in order to solve that problem, we have these groups where people negotiate who needs to do what, how important is it, and who gets which time on which antenna. And it's a very big, drawn-out, complicated process.